Hey, I'm Mako Bates. I've been working with my advisor over in Burlington for over a year now, trying to put together a system that can do static analysis, can automatically verify the security of implementations of secure multi-party computation protocols. I should be clear, this is a work in progress. We do not have a pMPC language. So the first thing to talk about is what secure multi-party computation is. It's a cryptographic primitive that's been implemented a couple of different ways, which allows a group of parties to compute some function across their secret inputs without sharing those secrets with each other. A nice, easy example to implement would be summation. It's proven, or I should say, proofs of security take a pretty normal simulation-based form. So what we need in order to show that a protocol is secure is some function that can, in an abstract ideal world, sample from the distribution of party views that you would see in the real world. If you can write such a simulator, then you know your protocol is secure. Our goal is a system that can automatically find simulators for a usefully large space of possible protocols. Turns out that's tricky. The details of the simulator matter a great deal. In particular, you have to include the random tapes, and you have to do what amounts to posterior inference in order to get valid random tapes with the correct distribution, even though you knew they were uniform to begin with. Efficiency is also a concern, even though you'll never actually run your simulator. In order for the transitivity argument to hold, you need it to be something that you could do efficiently in polynomial time. So one way of thinking about this, which we think is actually kind of fundamental, is we're doing posterior inference. So we can think of this as a very abstract causal graphical model of a protocol represented as a joint probability distribution across all of its inputs and outputs and internal variables. But if we want to think about it this way, then the honest secrets cause a problem because we can't make assumptions about them. We can't say they're sampled from some distribution X. Or really what we could say is they're sampled from some distribution X and our choice of assumption doesn't matter. So probably most people in the room understand this slide that I wrote better than I do, but the thing I just said is represented there on the bottom. Your choice of prior distribution for the honest secrets doesn't matter. If you can show that, then we can build a simulator, give or take efficiency, which is important. Similarly, you could just say it's conditional independence. Conditioned on the inputs to the simulator, the views and the honest secrets are independent of each other. Conditional independence, posterior inference are both hard to do efficiently, to do exactly. We've tried a variety of language features to simplify the problem. So using indistinguishability or non-interference to carry forward the uniform randomness of the tapes can help, or possibly restricting the distribution to a point distribution would obviously be very helpful, but you lose a great deal of expressivity. However, some compromises can be made. We don't need a completely Turing-complete language necessarily. We have, however, found a lot of things that don't work. Bayes nets obviously are not very efficient. Some product networks looked great until we realized that you can't actually represent existing normal MPC protocols within them because they violate the invariants. Dice looked really promising. However, we haven't been able to figure out a way of parameterizing it. We need to make these guarantees across all possible inputs, all possible outputs. And so when you have a network model whose shape depends on actual values in the program, how can we make the universal quantification we need? So I'm here at LAFI kind of shopping for solutions. Ways of doing exact probabilistic inference, ways of doing exact sampling, ways for enforcing conditional independence. My advisor and I are both coming into this from other domains, and hopefully we can convince you we know what we're talking about. I'll be at the poster session, obviously. I'll actually be around all week, so I'm looking forward to meeting most of you. Thanks.